In this recording, we're going to learn about a new coordinate system called the polar coordinate system. So we're going to be graphing not on an XY plane, but on an R theta plane. And our grid will look like this. It will look like a series of concentric circles that have different radii, and you can see that we've got the degree measures all the way around the circle. Of course, we could also use radians, but we're going to use degrees. So let's learn a little bit about it. First off, we're going to use a piece of notebook paper to take a couple notes on some of the vocabulary. We're also going to need a piece of paper that has some polar graphing grids. Okay, so let's create an angle here on our notebook paper. We're going to call the vertex of that angle the pole, which will always be called the origin. All right, it's at the origin or the pole. And the initial side is called the polar axis. All right, and you're always going to use the polar axis as your initial side. Okay, so we have this angle that is theta degrees, and if it's a positive angle, it's going counterclockwise. That should be familiar territory. We're going to call a point on our initial side A. I'm going to call this point here P. And as opposed to having the coordinates like x, y, it has coordinates r, comma, theta. So we're given a particular radius and a particular angle. Okay, so we also have an opposite ray that extends in the opposite direction from P. I'm going to call this Q. All right, it has a negative radius. And you might say, well, that's weird. How can a radius be negative? Well, it can in the polar coordinate system. It just means it extends in the opposite direction from P. So we have a radius that is negative of the same angle theta. Okay, so let's note a few things here. Okay, first off, R is positive when measured along the terminal side of the angle. And again, in this case, OP, we'll label it as a ray, okay? OP is the terminal side. On the other hand, R is negative when it's measured on the ray opposite the terminal side. And in this case, of course, OQ So now that we have a little background, let's graph some points. So you're going to need a piece of polar graphing paper. Now these pieces of polar graphing paper come in different radii. I have one here that has a radius of 10. Okay, so you can see it goes out. There's 10 concentric circles. The first thing you're going to want to do is label all of the radii. So go ahead and do that. Play the recording when you're ready. The other thing you're going to want to do is make sure that all the angles are labeled. Some of the pieces of paper don't have all the 10 degrees labeled, but this one does. So we're going to plot a point of the form r theta. So that's how we state the point, just like xy, although we are going to typically plot the angle first. Now, because we're new with this, first thing we're going to do is plot the angle. So let's create our polar side here. All right, this is our terminal side. And then on 60 degrees, create that angle. And then we're just going to want to go 4, a radius of 4, and plot right there our point P. All right, so we just plotted our first point on a polar coordinate plane. So this time we're going to plot it, but we're going to go negative 60 degrees. All right, so let's go down this way, negative 60 degrees, of course, takes us to the angle 300. And again, we have a radius of 4. So I'll label that point Q. Okay. Now we have a point with a negative radius, but still an angle of 60 degrees. So let's grab a different color here, maybe a purple. Hopefully you have a few colors at your disposal. So we're going to go 60 degrees as before, but we're going to need to go right through the origin and place our opposite side, okay, this opposite ray, over on this side. So did I call it the opposite ray before? If I didn't, let's do that. This is called the opposite ray. Let's go back and note that. So it goes right through the origin. And if you have a piece of paper, you can line it up with that so you're sure it goes straight through. So you have a straight edge. All right, so that goes straight through. And we're going to want to plot the point at a radius of 4. So again, find 4, swing it around, and that is point R. All right, and finally, we're going to want to plot point S. Point S starts out being an angle of negative 60. So we go down negative 60 degrees. But then we're going to go straight through the pole up the other side. Draw that angle, and then show a radius of 4. So that would be point S. All right, so a little introduction to that polar coordinate plane plotting points. Okay, so you try. Let's have you plot the point 5, 120 degrees, and then see if you can name 3 other representations for that point, keeping in mind that angles can be negative and radii can be negative. Then play the recording when you're ready to check your work. Okay, so hopefully you took time to do that. Let's plot the point by first getting the angle 120 degrees. We need to label this up, 1, 2, and now we swing around with a radius of 5. There's our point right there. Now, how else can we name that point? Well, let's see, we could have swung around negatively. How many degrees would that have been? That would have been a negative 240 degree angle with the same radius of 5. Okay, that would have gotten me there. I suppose we could also have some negative radii. So think about what that would be. What if I had negative 5 as the radius? Well, that would mean that my angle is actually on the other side here. So think about a couple different ways to get over on the other side here and then reflect across the pole. So to get down there, I would have needed to be at an angle of 300 degrees, going all the way around. I could have had an angle of 300 degrees. Or I could have, that would have been going around counterclockwise, or I could have come down negatively 60 degrees and then go across the pole. So notice that we have 2 angles that are negative and 2 radii that are negative. Okay, so these are our other representations. Let's just make a note there. Okay, so please note that you will have 2 positive radii and 2 negative radii. Also, 2 positive angles and 2 negative angles. Cool. All right, so what about graphing a polar equation? What would that be like? So far we just have points, but what about graphing an equation? Well, you could have an equation r equals 3. So this is sort of a basic one. So move to another grid on your piece of polar graphing paper. And let's start to plot some points that have a radius of 3. Okay. So, well, first off, I'm going to label up my radii. I want to start plotting some points that have a radius of 3. I'll use red here. There's a point. All right, all these points. Essentially, this whole curve, this circle, has a radius of 3. So that would be a polar equation. Simple. Looks very simple, right? Just has a radius of 3. All those points satisfy that. Okay. Last thing we're going to look at in this video is, on a new grid, a polar equation that has theta equals a particular angle. So be on a new grid, and let's once again label our radii. Okay, so how's this going to work? I need all the points that have 60 as an angle. So certainly this point does, right? As do these. So I can see I've got this line basically, right? This ray. And you would think that's everything, right? Just there. However, it's not. Okay? That would be the angle there, 60 degrees. That's only half of it, because keep in mind, you could have polar points with negative radii that have that as their angle. So you also need to go through the pole out the other side to all these points. So basically, the equation looks like that. Thanks for watching.